Hi everyone, in this video we're going to take a look at finding parametric equations for the line that is formed by intersection of two planes. Alright, so we got two planes and I went ahead and drew them over here in Calcplot 3D. So you can see that these two planes intersect at a line, right? So if I were to get a little bit closer here, you can see, right, that this line right here, this line, that would be the line of the intersection. So in order to come up with the equation of a line, you need two things. So first of all, you will need a vector that shows direction of that line. So let's just call that vector v. And you will also need some point on the line. And then if you have that, then you can went ahead and write the equations. Okay, so here is an observation that I need to make. If I look at the first plane, so let's just say this x plus y minus z equals 2. Now, what is a vector that's normal to that plane? So remember that vector, the coefficients 1, 1, and -1 give you the vector normal to the plane. Now, because vector v is at the intersection of the two planes, in particular, it belongs to the plane x plus y minus z equal 2. And so that means that the normal vector 1, 1, -1 is going to be orthogonal to v, right? Because any vector on the plane will be orthogonal to the normal vector. And so v should be orthogonal to 1, 1, -1. But also the same argument goes, and you can explain that v will also be orthogonal to 4, -1, 9. Now let's think about how do we find a vector that is orthogonal to two different vectors? And hopefully you already know that that is cross product. Now, in this particular question, it is not smart enough to recognize all possible answers because there is no just one vector that's a cross product, there are actually two. And there is actually also not just one vector that will show direction of the plane because you can scale it and it will still show the direction. But in this case, all you will need to do it, that's the only answer that is going to be accepted. If I can figure out how to do it, I will let you know. But unfortunately, at this point, it's just only one way that you can get it right. Okay, so how do you do that? So, okay, so first you just have to start with the first plane. And the vector that's normal to that plane would be 1, 1, -1, right? And in that order, you have to do it. Otherwise, it's not going to take it. Okay. So what we want to do is find the cross product of those two vectors. And that's going to show you that that's going to find that vector v that will show the direction. Okay, so cross product is you have the standard unit vectors, I, j, k in the first row. Then you gotta put that first normal vector first and then 4, -1, 9 second. And let's find the cross product. So let's just carefully look at it. So this is where we cross out the first column and the first row, and whatever remains, we multiply the main diagonal, which is going to be 9, subtract the product of the other two, which is 1, so 9 minus 1. Okay, for j, remember that the jth component comes with a minus, okay? So here we're going to cross out, okay, so let's use this one, the second column and the first row. Okay, so what do we get there? We will get 1 times 9, so 9 subtract 4 times -1, so we're subtracting -4. And finally, the kth component is going to be when you cross out the last column and the first row. And I don't know if you can see anything, but this is 1. Okay, so this is going to be 1 times -1, which is -1, subtract 4. Okay, so I think that the cross product is going to be 8. Then 9 plus 4 is 13, but there is a negative, so that would be -13 and -5. Okay, so let me actually check just that part, if that's correct. Now, by the way, okay, there is another thing I can do to check, and that is take the first vector and find the dot product of it with the answer, with the cross product, and that should be 0. So if it's not 0, then that's wrong. So, okay, so 8 minus 13 plus 5. Well, that is indeed 0, so that works. And then the other one was 4, -1, 9, and we are also finding that with the 8, -13, -5. So this may be a little bit more difficult to solve. 32 plus 13 minus 45. Yes, that is also 0. Okay, so I'm pretty confident that what I just found is correct. So now we want to find the point that belongs to each plane. Now, when I say the point, I should say a point. But there is only one point that would be the intersection of this plane with z equals 0. So it is possible that actually it never intersects, but in this case it does. So how do we do that? Well, because that point belongs to both of the planes and also z equals 0, so we just plug in z equals 0. That's just one possible point. And we will get x plus y equals 2, and then we get 4x minus y equals 8. Now, to solve this system of equations, you can add up the two equations, and y and negative y is going to cancel. So here you're going to get 5x equals 10, which means that x equals 2. Okay, so we got that. And then also because x plus y equals 2, that tells me that y equals 0, and z is also going to be 0 because that's how we found the intersection. So it looks like this point is just going to be 2, 0, 0. And hopefully that's right. Okay, and then use that point and that vector to come up with the parametric equations. Now, they're not unique. You could have chosen a different point, a different vector, but this code only accepts one, unfortunately, at this point. So you're going to just have 2 plus 8t. That's the first equation. Then 0, which I'm not going to write, minus 13t. And then 0 minus 5t. So that's it. Okay, so let's just see if that's right. Yep.